Science Chemistry for Kids. Kids should not perform these experiments without adult supervision. In this experiment, we will check the magnetic fields of magnet when passed through different material pipes. Let's learn something new about science. Take a PVC pipe. Take an aluminium pipe. Take a copper pipe. Take 3 bowls and place them under each pipe. Take 3 magnet pieces. Drop down the first magnet from the PVC pipe. When we drop down the magnet from the PVC pipe, it will fall at normal speed. Now drop down the magnet from the aluminium pipe. When we drop down the magnet from the aluminium pipe, it will fall slower than the PVC pipe. Now drop down the magnet from the copper pipe. When we drop down the magnet from the copper pipe, it will fall very slowly compared to the other pipes. When a magnet is dropped down through a copper pipe, it feels a resistive force. The falling magnet induces a current in the copper pipe, and by Lenz's law, the current creates a magnetic field that opposes the changing field of the falling magnet. Thus, the magnet is repelled and falls very slowly. In this experiment, we will observe reaction between cold drink and mint gum. Take a bottle of cold drink. Take a packet of mint gum. Place them one above the other. Open the lid of the bottle and insert. Take the lid of the cold. Pass a piece of thread from the lid and the gums. Tighten it with the clip. Now place the lid on the cold drink bottle. Wait for some time. You will see that lots of bubbles are created. This happens because of invisible carbon dioxide gas pumped into the bottle. Water molecules strongly attract each other, linking together to form a tight mesh around each bubble of carbon dioxide gas in the soda. It takes extra energy to break this surface tension. When you drop the mint gum into the soda, the gelatin and gum arabic of the mint gum break the surface tension. New bubbles need more space, and so the lid opens with a force. In this experiment, we will demonstrate different colors of fire. Take some copper sulfate. Take some strontium chloride. Take some sodium tetraborate decahydrate. Take some boric acid. Take some calcium chloride. Add some ethanol to the first powder. Repeat the process with all the other powders. With the help of a gas lighter, ignite the first powder. Repeat the process with the other powders.
You will observe that when the powders are ignited, different color flames come up.
Combustion in matter generally produces energy in the form of heat and light. The color of the flame depends on multiple factors: the type of fuel, complete or incomplete combustion, the type of material used, and most important, the type of radiation. Thus, when different materials are used, we can see different colors of fire. In this experiment, we will learn to serve tea from the teapot without lifting it. Take a teapot. Take 2 empty cups and place before the teapot. Take an air pump machine. Tap on the teapot. Open the lid of the teapot. Pour some water in it. Now close the lid of the teapot. Connect a pipe to the teapot and air pump machine. Slide the green button to put air pressure in the teapot. You'll observe water gushing out and falling in the first cup. Slide the green button again to increase. You will observe that the water gushes out with force and falls in the second cup. This happens because when you apply air pressure in the teapot through an air pump, the air occupies space within the teapot. Hence, the water gushes out from the teapot with force. In this experiment, we will demonstrate about bending laser beam. Let's do a new science experiment today. Take an empty bottle. Open the lid of the bottle. Take a jar full of mildly colored water. Close the lid of the bottle. Take a green laser light. With the help of the laser light, throw some light on the bottle. The laser beam is trapped inside the water because of total internal reflection. As the light tries to pass from the more dense water to the less dense air, it bends. This is called refraction. At a certain point, the light bends so much that it bounces on the surface of the water. This is called reflection. In the narrow column of water, the light wave continues bouncing on the boundaries of the stream of water, but cannot pass through the air. In this experiment, we will clean a copper pan using vinegar. And let's do an interesting science experiment. Take a copper dish. Take some salt. Repeat the process. Take vinegar. Pour some vinegar in the copper dish. Take a sponge. Take water. Take sponge and rub it over again. Take a paper napkin. Repeat the process. You'll observe that the dirty copper dish is completely clean now. This happens because copper atoms can combine with oxygen atoms from the air to make a molecule called copper oxide. Copper oxide dissolves in a mixture of weak acid and table salt and vinegar are acid. In this experiment, we will insert a needle in a balloon without popping. Let's do an amazing science experiment. Take a balloon. Take an air pump. With the help of the air pump, inflate the balloon. Take some oil. Take a needle. Now try and pass the needle through the neck of the balloon. Now try and move the balloon. You'll observe that the needle gets completely pierced without the balloon popping out. Balloons are made up of a lot of chains called polymer chains. They are so small that they are not visible to the naked eye. On the sides of the balloon, these polymer chains are stretched to their limit. At the neck of the balloon, the polymers are much less stretched. So when pierced with a needle, there is enough room to allow the needle to pass through the chains without breaking them. In this experiment, we will make fire extinguisher using baking soda and vinegar. Take some candles. Arrange them in a row. Take a gas lighter. With the help of the gas lighter, ignite the candles. Now put some baking soda with the help of spoon in the jar. Take some vinegar and add it to the baking soda. Wait for some time. Now take the jug near the candles. You'll see all the candles blow off, one by one. When baking soda and vinegar are combined, the immediate acid-base reaction creates carbonic acid. Carbonic acid is unstable and decomposes into carbon dioxide or CO2 and water, H2O. The bubbling that you see inside the container is the production of the CO2 gas. When you pour out from the container, you're exposing the flame to concentrated CO2 gas. The lack of oxygen extinguishes the flame. In this experiment, we will learn the concept of Dead Sea. Take an empty glass. Take some water. Now pour it into the glass. Take a small dish and put it in the glass. Take a golf ball. You'll observe that the golf ball will rest on the dish. Take salt. With the help of a spoon, put some salt in the water. You'll see that the golf ball floats. The salt changes the density of water, making it denser. The golf ball is now less dense than water, and hence it floats. In this experiment, we will make rocket from chips can with a plastic lid. Take a chips can with a hole. Take a balloon filled with hydrogen gas. Press the pump attached to the balloon. Take a gas lighter. Wait for a while. You'll observe that the can flies over like a rocket. A potato chips can is filled with hydrogen gas and ignited. The hydrogen burns with a yellow flame for about 1 minute. As the air mixes with the hydrogen, the flame will become smaller and smaller. Just before the mixture explodes, a slight whistling can be heard. When the mixture explodes, the plastic lid on the bottom will fly off and the can will shoot in the air. In this experiment, we will demonstrate friction and inertia using a nut. Take a beaker filled with water. Take a ring, place it on the beaker. Take a nut, place it on the ring. Now slide the ring. You'll observe that the nut falls into the beaker. Take a beaker filled with water. Take a ring, place it on the beaker. Take 2 nuts, place it on the ring. Now slide the ring. You will observe that both the nuts fall into the beaker. This happens because of friction. The force opposing inertia is friction. All bodies in contact possess friction between them to some extent or the other. There is friction between the nut and the ring. Thus, if we try to move the ring fast, the inertia of nut will try and resist that motion. Friction acts on the objects in the direction of the pull for very short time, and within that small amount of time, the nut will safely get into the bottle. In this experiment, we will see why breakfast cereals get attracted to magnet. Let's learn a new experiment. Take a bowl filled with water. Take a piece of cornflake. Take a magnet. Try and move it. You will observe that the cornflake gets attracted to the magnet. Many breakfast cereals are fortified with food-grade iron particles or metallic iron as a mineral supplement. Iron gets attracted to magnet, and hence some cereals get attracted to magnet. Science chemistry for kids.